mean value theorem. The mean value theorem is not only an existence theorem, but it goes a little bit further in that it tells you that the so-called derivative at a particular point C is equal to a number. Here are the preliminaries. Let f be continuous on the closed interval and differentiable on the open interval AB. Has the same criteria as in Rolle's theorem. So the mean value theorem then says that there exists a number C in the open interval AB. So thus far it's the same as for the Rolle's theorem. Rolle's theorem says now such that f prime of C is equal to 0. That means that you can find the derivative and the derivative is equal to 0, which is translated that you have a horizontal tangent. That means that the graph goes up and down, or it goes down and up. And so you can find a horizontal somewhere. Here, the mean value theorem does not guarantee a horizontal tangent, but it does guarantee a tangent, and that tangent is equal to the slope of the secant line. So here, f of b minus f of a divided by b minus a gives you the slope of the secant, and that line is going to be parallel to the tangent line that you get from f prime of C. That's a pretty neat conclusion. So there, our remark, the conclusion of the mean value theorem says that based on certain criteria, you will be able to find the slope of a secant line, that's the f of b minus f of a over b minus a, such that the slope of the tangent line will be parallel to it. Let's see. Here, if the mean, apply these problems, numbers 37 and 46, determine whether the mean value theorem can be applied to f on a closed interval. If the mean value theorem can be applied, then find all values of C in the open interval that guarantees that. So we take this problem. This function is continuous. F is continuous on the closed interval from 0 to 2, and f is differentiable on the open interval from 0 to 2. So if that be the case, then the theorem says that there ought to exist a C such that f prime of C is equal to f of b minus f of a all over b minus a. So we first find the derivative f prime of x. That gives us 4x to the third minus 8. Now we're going to find the slope of the secant. So we need f of b, which is f of 2. So that gives us 2 to the fourth minus 8 times 2. That gives us 16 minus 16. We get 0. And then f of 0 is 0. So f prime of x is said to equal to f of 2 minus f of 0 all over 2 minus 0. Well, this gives us, this f prime is the 4x to the third minus 8. This side over here is 0, right? This was 0 minus 0 all over 2. So we get 0. So this is equal to 0. So now we solve for x. So we get x to the third is equal to 8 divided by 4. So we get 2. This implies that, here x is equal to this cube root of 2. Okay. Now, is the cube root of 2 on the interval from 0 to 2? Yes, it is. This is on the interval, the open interval from 0 to 2. So, therefore, we take c to be the cube root of 2. So, we come here. So, is f continuous on the interval from -1 to 2? No. F is not continuous on the closed interval from -1 to 2 because f of 0 is equal to 1 over 0 and it's undefined. Therefore, the mean value theorem cannot be applied. So, got the next problem. So here, f of x equals the square root of 2 minus x. Let's check the continuity. Notice that 2 minus x is greater than or equal to 0 for continuity. This implies that x is less than or equal to 2. Now, this interval, f is indeed continuous on the interval from -7 to 2. F is indeed continuous on the interval from -7 to 2. And may we add that f is here also differentiable on the open interval from -7 to 2. So here, the theorem guarantees that the tangent slope is equal to the secant slope. So thus the theorem guarantees that there exists a C such that f prime of C is equal to f of B minus f of A all over B minus A. So here we find f prime of x. We get 1/2 times 2 minus x to the -1/2 times the derivative of the inside, which is -1. So this gives us -1 all over 2 times the square root of 2 minus x. And we find f of b, we find f of a. So f of b is f of 2, and this is the square root of 2 minus 2. We get 0 there. F of a, if you can read it, is f of negative 7. And this is the square root of 2 minus negative 7. So this is the square root of 9. That gives us 3. So if that's the case, then we have that derivative, which is the negative 1 over 2 times the square root of 2 minus x is equal to f of b, which is 0, minus f of a, right, which is 3. And this is all over 2 minus the negative 7. 2 minus a negative 7. So we get negative 3 all over 9, and that gives us negative 1/3. And so we put everything together. So we have negative 1 over 2 times the square root of 2 minus x is equal to negative 1/3. The negatives cancel. And this implies that 2 times the square root of 2 minus x is equal to 3. Square both sides, divide both sides by that 2 as well, and so we get 2 minus x is equal to 9 over 4. X is equal to 2 minus 9 over 4. So we get 8 minus 9, that's negative 1 over 4. The question now is x equal to negative 1 over 4, is that on the interval from negative 7 to 2? And indeed it is. This guy is on the open interval from negative 7 to 2. So we conclude that c is equal to negative 1 over 4. That guarantees here the mean value theorem. Thank you.